the organization of the engineering facility. Okay, so what does it entitle? First of all, the organization. The plant engineer should have, and remember this is now orientation with regards to the plant engineer. Okay, the plant engineer should have a direct access to whoever makes the final decision on any project, capital expenditure, the legal concerns, and also the enterprise policy decision and decision makers. Okay. Also, it should multi-site companies with a corporate engineering department. Each site plant engineer should report directly to the site manager with a secondary reporting relationship to the director of the corporate engineering. Okay, we're going to continue with this, the engineering function basically. So what is it all about? First of all, the management side of things. The engineer fills a management role, all depending on his position, of course. Is he in a senior position? Is he in a junior position? Also, there is the technical function, which also includes the design function of things. Then there is the supervision. All right. So if you have draftees reporting to him, obviously in the engineering department there will be trades and all those kind of people. And then there's also a guidance function where he needs to guide people underneath him, also giving instructions. And you also need to anticipate what might go wrong, or what will the next move be, or what any future development might be in the process of the plant. So the organization of the plant, that's the next one. It is worth noting that a few very large industrial companies have divided the plant engineering function into multiple departments. Okay, the most common division in these cases is the separation of the landlord responsibilities. That is basically the real estate or the buildings and grounds, utilities, etc., from the production side of things. Okay, that is the manufacturing and the process equipment side of the systems. The next slide will basically continuing on the organization of the plant. Within the plant engineering function, there are typically two primary sub-functions, best described as engineering and maintenance. Okay, so all of you will have to do with the engineering side of it or the maintenance side of it at one stage or another. The engineering sub-function is responsible for such matters as the design and the construction side of things. Okay. So engineering function number 2 is also the support ongoing operations, troubleshooting, resolve emergencies, implementation, and also shutdown of things. Also to organize and maintain information on plant systems, equipment and improvement programs, implement plant projects and maintain proper documentation and maintenance. The engineering function deal effectively with multiple activities, requests, emergencies, also to management the scope of work basically, the design phase of things, specifications, procurement side of things, the installation. He is also in charge of the startup, debugging meaning troubleshooting where they need to sort out any little debugs and things, validation, and also the training side of things. Engineering function continuing. Plant engineer is that branch of engineering which embraces the installation, operation, the maintenance, the modification, modernization at a later stage in the plant, and the protection of physical facilities and equipment used to produce a product or provide a service. It is easier to describe the plant engineer than to define it, okay? Yet the descriptions will vary from facility to facility and also over time. So the engineering function, continuing, every successful plant is continuously changing, improving, expanding, and also evolving. And the activities of the plant engineer must reflect this environment. Each plant engineer is likely to have its own unique job description, and that description is likely to be different from the one he had 5 years earlier, or that he is going to have 2 years from that point. The primary mission of the plant engineer is to provide optimum plant and equipment facilities to meet the established objective of the business. This can be broken down into these 4 fundamental activities. The first one there, ensure the reliability of the plant and equipment operation. Second one, optimize the maintenance and operation cost. Thirdly, to satisfy all environment and other regulations, also with regards to safety. And the fourth one is to provide a strong element of both short-term and long-range facilities and equipment planning. The next one, 1.3.1 is activities. The activities that plant engineers must perform generally fall under the responsibilities of middle to upper management. Like all managers, they plan, organize, administer, and also control. Okay, but most specifically, the plant engineers are involved in or are in charge of the following activities: design of facilities and also the design of the systems, construction of the facilities and systems, installation of these facilities and systems and also of the equipment, operation of utilities and services, and the maintenance of facilities, systems, and equipment. Improvement of retrofit and redesign facilities, systems, and equipment, planning to meet business needs, contracting for equipment, materials, and services, project management, including planning, estimating, and also the execution of it, administration of the plant and engineering organization, and personal as well as related financial considerations. For instance, the budget, forecasting, the cost control side of things, also part of the estimating, training, and record keeping as well. Regulatory and compliance with a wide variety of governmental laws and standards, so you need to take care of these as well. Coordination of the plant engineering activities and responsibilities with all other functions and departments in the organization. Purchasing of requisite tools, equipment, parts, and also the materials. And these activities are nearly universal throughout the plant engineering function, although they may be described differently in specific companies or facilities. Also, other activities might be added to these lists. Plant and engineering function. The plant engineering focus on the installed plant and equipment. In this category, the maintenance is now the main focus. All right, this is after the whole process has gone through of installation. So the maintenance focuses on the type of maintenance, the time-based, condition monitoring, predictive maintenance, and also a combination of all of the above. So he also has to deal with different projects at different stages of it. Let this one go on. Okay. Thus, to be successful, the plant engineer must be knowledgeable in the design, okay, the installation, operation, and also the maintenance of the following: electrical power systems, electrical machinery, mechanical systems, and also the civil systems. So if you have gone through the design phase of your career, say you are a mechanical engineer or electrical engineer, you've been exposed to the design phases of various, may that be mechanical, electrical, or whatever, then you will have a background for these design for the installation, the operation, and also the maintenance of these various categories that the plant engineer are exposed to. Okay, guys, so here's a little example that you need to be aware of, for instance, if you are a plant engineer. Okay, in this case, this is a little a diagram of what are all the bits and pieces, maintenance operation functions. So you need to be aware of what, for instance, is a vacuum bottle, what's the isolator, what is the bus bars. You know, if this is all in the electrical field, and you need to be aware and exposed, for instance, to these categories. Okay. In this case, the next sample is basically a diagram for connections of an IDMT relay. IDMT is basically an inverse definitive minimum time relay. Okay, so how do these things work? You need to be familiar with it and basically solve any issues and problems with regards to these. This is fairly complicated electrical systems, and for electrical engineers, for instance, and we're not going to go into detail. This is just an example of what you might be exposed to. In the next one, relationship load, speed, and torque. So this is a torque speed characteristic of induction motors. So basically what it all is about, the figure shows the typical torque speed curve of a three-phase AC induction motor with a fixed current. So when the motor starts, there is a high starting current and also a low torque, pull torque, basically to torque. All right. So when the motor reaches its 80% of the full speed, the torque is at its highest level, and that's your pull-out torque, and the current begins to drop, as you can see it there. Okay. If it is at a full speed or synchronous speed, the torque anticipates the current drop basically to zero. The next one. This is basically power and power factor. Power in a three-phase distribution system consists of two components, namely the active or real power, which is P, all right, and the reactive power, which will be Q. So the complex sum of the two gives a parent power S, so hence S equals P plus JQ. Okay, this illustrates in the well-known power triangle in figure B.11. All right, so there you have the power triangle, where in this case XL is the inductive reactance, XC will be your capacitive reactance, Z will be your impedance, and that will be equals to R plus J times XL minus XC in brackets. Okay, R is always your resistance. I don't know if you know the VIR table or triangle. Let me just select a pen, then I can explain that to you guys quickly. I just need to select that. Okay, so it's a triangle that's basically sitting like this. Okay, and it's broken up like that. And in there you have your V. Okay, in there you have I. All right, and in this one you will have R. Okay, and that will be those three there. Okay, so resistance, current, and voltage. V, voltage. Okay, so V will be equals V equals I, all right, times R. Okay, and if you want R, it will be R equals, all right, V divided by I. The same with I. That will be V divided by R. Okay, and that's those three there. Resistance, current, and voltage. S, again, is as it says there, your apparent power. Q is the reactive power, and P is your active power. Okay. So, plant engineering functions, guys. First of all, you need to look at lighting, the fluid power transmissions, for instance. Mechanical power transmissions, you need to be knowledgeable in those areas. Instrumentation and control, so that's all to do with piping and instrumentation. Heating and ventilation, so you need to know a little bit about heating and ventilation, or also HVAC, all right? That's the air conditioning and the refrigeration part of it as well. A little bit about pumps, piping, valves. The EIT is also giving an excellent valve course. material handling and storage side of things as well. So if you are on a mine, for instance, there's a lot of material handling equipment as well. Paints, coatings, and corrosion preventative maintenance, fire protection. You need to know a little bit about engines, for instance, lubricants and lubrication systems, environmental control systems, and also compliance, compressed air systems. So it's a very big field that you as plant engineer need to be aware of. Okay, guys? All of these things basically has to do with one another in some stage or another. So minimum work in a multi-stage compressor. This figure basically tells you stage 1, all right? T2 will go to T1 in P1 stage, all right? And then from there, the pressure will go higher, all right? So T3 will go again to T1, all right, in the next stage of the compressor. This is basically with the intercoolers. So the pressure goes higher each stage. You can get a second stage, a third stage in each stage. It won't go directly from stage 1, for instance, to stage 3. So guys, here's another. A gas mixture comprises 40% volume percent of methane. So that's the molecular weight, all right? And 60% volume percent of hydrogen, MW2. The molecular weight of gas in the mixture will be what? A, B, C, D. So this is also the kind of things that you guys need to be aware of. Okay? Internal energy changes when there is an exchange of the following between systems and surroundings. So when will the internal energy change? When there is a heat change, a work change, a mass change, or any of the above. Okay, so these are all scenarios that you guys might be aware of, or that you guys might be involved with. Again, this is basically cylinder, all right? Stroke basically, piston, or some call it a cylinder. You will have inlet, outlet, all right? So it starts with 1 basically. Okay, PS this one here. Okay, so you get air in, the cylinder pushes out that way, all right, the distance of the stroke. Then it returns with 3, okay, and then it's basically a cushioning function, and it will return to its original position. So that's another field that you guys need to be aware of, for instance, cylinders, pneumatics, and so forth. Plant engineering function, we're going to continue with this. You need to know a little bit about buildings and construction, also about tools, welding and joining, the safety and health equipment and practices, and you also need to know a little bit about security. And that's not security guards at the gates, but the security of machines, for instance, how they're going to close something off with pulleys or belts or anything like that, the guarding of motors and so forth. Principles of organization. Next one. From this discussion so far, it should be clear that the plant engineer must have a sound knowledge of many engineering systems and also their disciplines. Engineering activities must be undertaken with an open mind. Okay, so you as the plant engineer need to be able to identify any of the areas or terrains that you are going to be exposed to. The next area we're taking a look at is basically the leadership part of it, lack of leadership support, the lack of effective culture change, lack of willingness to evaluate systems and resolve problems, also the lack of trust, a breach of confidentiality, which can sometimes be a serious problem, a lack of ease of reporting, which also needs to be addressed. So the organization structures. The organizational structure in general engineering are many and with many variations. Okay, so you need to look at the factory, consultants or consulting, corporate, commercial side of things, and also the fire side of things. So here you have a little diagram, all right, with your general manager, GM. Then you have support functions, and underneath that you have your production, engineering, and finance. There is a lot of other legs of the systems as well, but these just as an example, 3 areas. So organizational prerequisites could be many, and also depends on the company culture as well. Again, brings us back to engineering manager, for instance. On his side, you will have a planner or a planning department. Engineering manager will also have various disciplines underneath him, for instance, electrical, mechanical, utilities. You will also probably be in charge of the maintenance side of things.